TaskTree is coming to Qt 6.11, but it's already available for testing in the tech preview. Now, a lot of the talk about TaskTree surrounds multithreading. It's easy to fall into the trap of thinking that TaskTree is only applicable when multi-threads are involved, but that's not true. TaskTree changes the level we work on, from wiring threads, signals, and callbacks to describing asynchronous workflows. It's not meant to replace your threading tools, but rather it orchestrates the asynchronous work on top of them. Now, why it is important? Why people are talking so much about how it will change the game? Why? The answer is modern Qt apps need to do a lot of asynchronous work, like talking to devices, calling REST APIs, running Qt process, reading files. TaskTree allows you to describe those steps as a recipe. Which part should run in sequence, which in parallel, and what should happen when something fails. Then it handles the orchestration.
Not quite my tempo.
If you are interested in multithreading in Qt, I highly recommend you go and check out our free presentation made by our amazing CTO Adam Sowa. And special thanks to our friend Jarek Kobus from Qt Group, who is the author of TaskTree. He helped us validate the concepts we talk about in this video, because for a subject as complex as TaskTree is, it's best to reach to the source. Also remember to like and subscribe, and let's get to it. Let's say we have some sort of device here with a control panel, like classical HMI, and we press some buttons. We do the thing, right? We press start analysis or load data or connect to device, and then the UI freezes.
Well, we're waiting.
The screen locks up, the spinner just hangs there, and nothing really happens. Imagine the situation happens to an HMI of a production line or a medical device. Like, that situation could actually be dangerous. And on top of that, the operators quickly lose any sense of trust to this system entirely. The fault is actually on us, the developers, because we've asked the main thread to do everything, to draw the UI, to handle users' input, to connect to hardware or backend, so that one worker was juggling too many jobs and he dropped the most visible one, the UI. That's the reason why we are using multithreading and asynchronous APIs in the first place. So the heavy work runs in the background, the UI stays responsive, and time-critical or long-running processes don't block the main event loop. And that's exactly the kind of situation where TaskTree can actually help you, not by making threads for you, but rather by organizing the whole flow of those backend operations. So if multithreading and async work is so important, why is it that implementing real workflows often feels so chaotic? To better illustrate my point, we'll use a very common example, which is application updater. On a whiteboard, it looks simple. Like, you check if there's an update, you fetch the list of files, you download them, verify them, and install. Plain and simple. Maybe you want to speed things up by downloading files in parallel, just to make it a little bit faster. Nothing crazy, simple, linear workflow. Now try implementing that in a common imperative style. Suddenly you are not just saying what should happen, you are micromanaging how everything happens. And that's a big difference. You start worker threads or kick off async jobs. You connect signals for finished, error, or timeout. Then you have to check what files are still in progress, maybe add some retry logic to flaky network calls, and you decide when it's okay, basically, to move to the next step, when everything succeeded, or even if some parts failed. The nice linear workflow that we've described on the whiteboard gets shattered across your code base. Now, 6 months later, you go and revisit this code, and you don't see the update process. You see a bunch of reactions. Like, if this signal starts, then do this. If it fails, set a flag or maybe abort. It works most of the time, but it's fragile, and every update, every change feels really risky. That's the reason why developers don't like to do this, because one misstep and you have to spend a lot of time fixing it. And if you are working on industrial or medical software, that can actually be dangerous for patients or for users. TaskTree is a library that was originally created for Qt Creator itself. The core idea looks like this. Instead of coding how every step runs, you describe the workflow, and TaskTree handles the orchestration and asynchronous tasks. And those tasks are not limited to a separate thread. A TaskTree recipe can consist of a queue process that runs an external tool, or a queue network reply that calls an API, or a queue concurrent call that's running on a worker thread. So TaskTree does not replace your threading tools. It sits above them, coordinates the work. Now what you do is you describe what steps exist, which are sequential, which can run in parallel, what to do on an error, and what data is passed between them. Now, how you manage that? Well, TaskTree gives you some building blocks. You have a recipe, that's the blueprint for the entire workflow. Then you have tasks, the actual units of work, like process, network calls, timeouts, something like that. Then we have groups, containers that run tasks sequentially or in parallel, and can be nested. Then we have workflow policies, rules like stop on the first error or run everything then report combined result. And the last one is storage, shared local storage for passing data between tasks inside the workflow. So yes, you still have to write what each task does, but you don't have to handcraft all the glue code that makes it into a coherent flow. Now, I would not suggest to rewrite everything to TaskTree on day one. We still need some real-life examples of how this would behave. Qt Creator right now is a great example that TaskTree can handle a complex workflows, but we need some more examples. Just that. The other thing that was not clear from the documentation, to me at least, was the debugging. That's why I've reached out to Jarek Kobus, the author of TaskTree, so to get some insight how this looks. One of the big promises is clarity. You will have one single structured view of the entire process. And on top of that, TaskTree already offers some useful tools. You can attach logging to a task or group and get informed about start, end, duration, result, and whether it ran synchronously or asynchronously. You can still set breakpoints in handlers and step through the logic. So without going into very low-level debugging process, it's great to see that there is some support here. Now, the next big thing we need to talk about is the adoption curve, because TaskTree brings a new mental model to the stage. Instead of reacting to signals and events, you have to describe recipes and policies. Some teams will love it, some teams will hate it. We need to see how it will turn out. With continuous support, I think TaskTree can be the go-to way of structuring asynchronous workflows that works beyond Qt Creator, but as a separate tool. Whew. We've reached the end of this video. I hope you enjoyed it. Be sure that we'll make more content about TaskTree here on our channel, because at Somco Software, yes, we see a lot of potential here. Now, if you are interested in multi-threading, remember we have a free presentation made by our CTO, Sowa. It's a very complex and deep dive into the topic. Also, big thanks to Jarek Kobus from Qt Group for helping me with this video, with explaining me how some things work in TaskTree and what it is actually capable of. If you find this video useful, maybe send it to someone who struggles, who wrestles with back logic and complex workflows. Thanks for watching, and I see you in the next one.